Welcome back to the second half of my presentation on the case history, where we had a transfer of care patient come from an outside clinic and we had to deduce what was going on with their cochlear implants. I'm still Jure, and I am still fulfilling my contractual obligations. So, in order for us to reestablish where we are, get a quick recap going. The patient has bilateral cochlear nucleus 7s, 86-year-old male, and he came in from Utah. The appointment date and time. The initial presentation just went over what happened on January the 8th, but now we'll continue on to January the 10th and January the 17th. And again, his primary complaint was poor sound quality from his cochlear implants and an audible hissing sound that was sort of constantly playing in the background. Here is his incoming map once more. The map on the left is for the right cochlear nucleus. The map on the right is for the left cochlear nucleus. And as you can see, a good amount of electrodes are deactivated on both sides. And then again, we have the parameters here. Nothing is too out of the ordinary except for some of the pulse width differences and some of the pulse rate differences relative to their internal devices. We did the audiogram with the sound field thresholds. All the ones that say CR or CL are the sound field portions, and then all the ones with the circles and the X's is the residual hearing that that patient has. Keep in mind, this patient got implanted a couple years ago, so this residual hearing is likely to remain as stable as any other hearing loss would be. So what were the questions from the last presentation? So what would you do with this map to help the patient have better speech audibility? What would you do with this map to address audible noise? And what physical change do you think we made to the sound processors? So, what did we do with the map? So we had one commenter give us an idea. One MVP commenter said, I would completely do his maps over again. And that's exactly what happened. We hit the factory reset on those maps. Do not save this one. Lost cause, let it go. Just start from scratch. It's way better than trying to fix something that's that broken. We did a remapping, and we included testing some of those electrodes that were previously deactivated. We didn't have any information on why they were deactivated. They just were. And so when we sort of retested with the impedances all within normal limits, and then we did some loudness scaling, set new T and C levels, the patient actually performed pretty well on a lot of those electrodes that were deactivated. And so we kept them activated except on electrodes 1 and 2 on both sides. And that was because of the rather poor dynamic range that those two electrodes had. All the rest of the electrodes had a dynamic range of around, at least 20, 22, which that's not perfectly ideal, but it is enough to where you can get some resolution to the auditory input that is coming from those electrodes. So now we have electrodes 22 through 3 on both sides. Now, the pulse width was set at 37 with a 900 pulse rate bilaterally. There's now not a difference between processors on which pulse rate they are using. Like I mentioned before, C levels were set with the loudness scaling method. T levels were set at first detection, so we didn't use ESRT C level setting for this patient. And again, as I mentioned, electrodes 1 and 2 were deactivated on both sides due to the poor dynamic range. Last time when I showed you the residual hearing in the cochlear implant sound field thresholds, I said that, hey, we made some changes before we did this. We had to. So this is the time where chronologically the audiogram and the sound field thresholds were measured. So now you're sort of reset on where this fits in the general timeline. Once we saw this, we saw the residual hearing, we saw the sound field thresholds. We kind of liked where our T levels were. This was a great starting point. It definitely should have given the patient some more audibility. But that residual hearing there, I mean, he's got mild low frequency hearing loss on the left side, moderate on the right side, and his hearing loss stays above severe levels for a good ways. Like, it doesn't hit severe until about 750 hertz. So what changes did we make based off the audiogram given those sorts of parameters? Again, MVP coming in strong with the comment, did you add a hybrid component? The answer is that's exactly what happened. So remember, the hybrid component on the Nucleus 7, you have a hearing aid receiver. It's just like one of the Oticon receivers. You put a dome on it, and then the low frequency portion of the hearing range that the patient has will be stimulated acoustically through the actual like RIC receiver, and then the rest of the frequency spectrum will be stimulated by the cochlear nucleus processor for all the mids and highs. We did add hybrid hearing to both sides. So we did that to utilize the residual low frequency hearing and to address the patient's lack of bass perception. So length 3 100 dB receivers were put on both processors, and we set the acoustic electric crossover at 866, 813 hertz. So the acoustic will stimulate up to 866 hertz. The cochlear will start stimulating at sounds at 813 hertz and above. And if you're asking why are those numbers so arbitrary, it's just because the software only allows you to set certain crossover points. So we couldn't make it like perfect 750, 750. But ideally, you don't necessarily need a large crossover. Like you don't need this big overlap between the two numbers. So 866, 813, there's only a very limited range where the acoustic and the electric component will be working at the same time. You can set it to where these two signals can overlap quite a lot, but I've yet to find much clinical utility for that overlap. Usually we just try to minimize it and make sure that overlap is relatively small. The patient tried the hybrid hearing between appointments, and the notes he gave back to us on his follow-up, which was a couple days later, was that it was much better for single voices, and he got a lot more music appreciation with the hybrid components. However, he said it was worse for ambient noise and speech and noise. So I'm not necessarily surprised by that because we gave him back a lot of low frequency hearing in one shot. And, ambient noise, steady state noise tends to be low frequency. I'm sure that noise stuck out to him like crazy. He hasn't been hearing it for a long time. How do we address this? What we decided to do was we will give him two sets of maps. One that uses the hybrid hearing component, another set that just uses the cochlear. So that way, when the patient is listening to music or he's in a one-on-one situation, he can use his hybrid maps. But when he's in noise, he could flip to the cochlear implant only maps and avoid that sort of acoustic stimulation from the receiver. So after the initial adjustments, he said, I'm quite pleased with the maps you installed the other day. The hisses and eeks are much less intrusive. The acoustic complement is quite helpful for voices and music. Giving the brain some time to figure things out, I'm sure will move us forward. Thank you. Thank you. Again, this is good. I mean, the patient sort of has our mentality, so that made the counseling relatively easy once we got him the results we were after. But again, this was still a situation where speech and noise still needed some more work. We're moving in the right direction, but there's still a couple of small adjustments that can be made. So the patient came back for a second follow-up on January 17th, 2024. And a lot of this was just to address some of the speech and noise and to give more of a separation, more gradients between soft sounds and loud sounds. So the only real change that we made was we increased C levels by 10 CUs on all active electrodes on both processors. So some of those high-pitched electrodes, which didn't have a great dynamic range, we made that dynamic range a lot more ideal. So the dynamic range was more like, 30 to 37 CUs instead of that 20 CUs. So this allows us to have a lot wider of a gap and give a lot more resolution, and make soft sounds and loud sounds a lot more different from one another. And so this was the final map that we arrived at. And as you can see, we have pretty good separation on all electrodes. And then also a lot of the C levels are right within that sort of shaded population mean. Not that that necessarily is indicative that you're doing your job 100% perfect. There are people who don't fall within population means just because of the definition of what a mean is. But it is sort of a subtle indicator that we might be onto something just because, this is more in line with a typical cochlear implant map instead of the wacky one we got presented with. So the final programming settings. Program 1 and Program 2 were the same on the both processors. So it was map 118 on the left, map 119 on the right. So Program 1 was scan with all the typical, zoom, adro, wind noise reduction, all that. And we used we call that one the everyday program with the hybrid hearing component active. Program 2 was all the same, but we used Zoom, so the forward-facing CI microphone array, and we called that one Restaurant, but we had all those sort of noise reduction components still active. Then if he flips to program 3, that'll do map 116 and 117 in his CI, but it will remove the acoustic stimulation. So it will be just CI only. And then that one has the scan version, and then the program 4 is the Zoom forward-facing microphone array version. So if he wants the acoustic component, maps 1 is the regular, map 2 is the in noise. Then if he doesn't want the acoustic component, map 3 is the regular, map 4 is the in noise. So that's the breakdown of his mapping right there. It uses all 4 slots, but it gives him a lot of utility to adjust how he is hearing given his surroundings. And after the final adjustments were made, he was just elated. I mean, you can read this word for word, but the takeaway message for this is that he feels that this is far superior than what he walked in the door with. And that shouldn't be too surprising, just because activating some of the electrodes that were deactivated for not a great reason and improving dynamic range should improve speech intelligibility and sort of that auditory spatial separation between background noise and speech. It makes it a lot better. So now we've gone through the questions I answered. We've gone through what we did. You've seen a sort of interesting solution where a patient can use both hybrid and CI only acoustic or electric stimulation with their processors and have that be a viable solution for them when they have sort of a wacky complaint. Now, if you have any further questions or anything else that you want to know about this presentation, it's too damn late. You had your chance and you need to keep that crap to yourself.